Ladies and gentlemen, we have been discussing differentiability of things, and we're going to get to the point where we're looking at graphs of them. When would you not be able to take a derivative? When can't you find a derivative? And the answer is pretty easy. A derivative is just the slope of something. So when can you not find the slope? We're talking about the slope, not between 2 points, but at one particular point. So there's a few things here. First off, cusps and corners. You can see where these come up to a point right here. Well, that's known as a cusp if they are on the curve of a function. That is impossible to figure out the slope of the tangent line because there isn't one tangent line there. As a matter of fact, there's oodles of them. You've got a straight line. Wow, that's not showing up very well. But I've got a straight line here that if it's tangent, it goes through at only one point. How do I know if it's going like this or that? There's an infinite number of possible tangent lines there. As a matter of fact, what we do is we say, the slope as we're approaching from the left is getting closer and closer to one number. And if we're approaching from the right-hand side, the slope there is getting closer. We have a positive slope on the left. We have a negative slope on the right. If there really is a slope at that one point, it's going to have to be the exact same number that's approaching from the left and the right. And if they're different, it's not going to work. But anyhow, I like to say no derivatives at the pointy bits. Other pointy bits are known as corners. That's where you have a nice linear graph and another linear graph forming a corner. So corners and cusps, the pointy bits, do not have a derivative. Also, undefined points. You've got a hole here. There's no derivative there. You have one point all by itself up there. You draw a tangent line through that one point. Can you draw only one tangent line? So an individual point can't find the slope of an individual point. If there's a point missing or a break in the graph, there's no way to tell what the slope is right here. At the end point, we could find the slope of the tangent line at any point going along this curve until we get to the very end point where you could say, wow, there are a lot of different lines that could go through there at exactly one point. There is no one specific tangent line for an endpoint. Now, why would a vertical line, let's see, I guess right there, why could we not find the slope there if the tangent line's vertical? Because what is the slope of a vertical line? It is undefined. So this is a quick little kind of theorem that comes along with this. Differentiability implies continuity. Just in short form, if something is not continuous, it's not going to be differentiable. If it is not continuous, you can't find the slope at that point. In the first one, there is no point right there. So there's no slope right there. You can't take the slope of the point if there's no point. There's a break here. Endpoints do not have a slope. You can find the slope or the derivative at any point along this line except right there. Because on the endpoint, there is no one particular slope that exists. There's not one tangent line that goes through this. And then finally, if there's a break in the graph, obviously, there's no points, there's no slope there. It's not continuous. There's not even a slope at the endpoints themselves, but every other part of those curves, you could find the slope of a tangent line there. Just for the terminology, to remind you, you got a couple lines coming together, those are called corners. You have a couple curves coming together, those are called cusps. But the overlying idea here is you will not find a derivative at the pointy bits. No derivatives on the pointy bits. And by the way, these aren't just like limits. If the slope is approaching a different value from the left than it is from the right, that slope doesn't exist at that point, meaning there's no derivative there. Just like limits, the left and right-hand side limits have to approach the same value. The left and right-hand side slopes have to approach the same value for there to be a slope right there at that point. If they're different, no slope. I hope I beat this to death. It's pretty easy.